motion, falling or throwing objects. Dave throws a ball upward with an initial velocity of 23 feet per second. The ball initially leaves his hand 5 feet above the ground and eventually falls back to the ground. In parts A to D, you will answer the following questions. What is the maximum height reached by the ball? After how many seconds will the ball reach its maximum height? How long will it take the ball to reach the ground? So this video is going to be in 4 parts. Because it is going to take a long time, I want this to make a little bit shorter, in each part to take at least 5 minutes. So now let's go in the part A. Part A and B. What units will be used to solve this problem? According to this problem, we are using the formula for the motion, for the falling object in the motion, which is equal. So let me take one pen here. And the formula is H is equal with 1.5 the gravity pull G times T squared plus velocity times T times plus the initial position when the time is 0. So this is h of t, the height of the object. So let me write here h of t. So the h of t is going to measure in meter or feet. If, for example, we are using the system metric, the units are going to be meter or feet. Feet are in the American standards. And now, if we are using this velocity is v0, and g is a meter per second square. Meter per second square, or units are feet over second square. Depend on what units is given the problem to solve it. And v0, initial velocity, the units for initial velocity are meter per second or feet per second. Or feet per second. And the initial position when time is equal to 0, so the units are meter or feet. So those are units for this formula, what we have here, what we needed to use for solving these kind of problems or modeling these kinds of problems. And in the B says, what information from the contextual description do we need to use to write the formula for the function of the height of the ball versus time? Write the formula H for the height of the ball in the feet ht, where t stands for a second. We already have here. But the gravity here is, for example, if we are using a metric system, is 9.81 meter per second square. But if we are using American standards, is 32 feet per second square. But let me write both the formulas. So this is for, first of all, I am writing this formula when we have the gravity, pull gravity is -1/2. If we have, for example, for the metrics, is 9.81 divided by 2 is 4.9. Is 4.9 approximately. T square. So here I'm not writing the units any further because we know already h of t is going to be for meter in this case, plus v0, initial velocity, time t, and is plus h0. But because of the gravity here, the pull is downward, the sign is going to be negative. But if we have, for example, this is in metric standard. If we have in US standards, in American standards, we are using 32 meter per second, 32 feet per second square, the gravity, and 32 divided by 2 is 16. And because it is the same, the sign is negative because it's down, the gravity is downward, and minus 16 t square plus v0 times t plus h0.